Years back, I worked at Computer Gaming World, and since I'd done some pilot training in real life, I got to review the flight sims. This led in a roundabout fashion to the best day of my life when the Air Force invited me to fly in an F-16 fighter jet, which I always thought was the coolest looking airplane ever. After the pilot took me on a low-level run through Death Valley, which was honestly a bit terrifying, I got to fly the plane myself for about 20 minutes and do some aerobatic maneuvers. Here's me trying a split S. This was an incredible experience, but I could not help thinking about it from a user interface perspective. I was amazed by the feeling of the controls and how well the aircraft responded to the subtle movements of my hands. It really felt as if I'd become one with the plane. It's not much more than a jet engine with a chair strapped on top, and it feels like flying through the clouds in a dream. Just the little taste I had was the most compelling example I've ever experienced of the flow state when the mind, eyes, hands, and machine are all working together at a heightened level. From a design perspective, I would say that a jet airplane certainly allows you to really push the boundaries of your triangle of limitations. It was definitely, by far, the coolest chair I've ever sat in. Unfortunately, I've not done anything nearly as exhilarating since. Instead, I've been immersed in the comparatively sedate world of technology, software, and design. But my interest in user interfaces and the flow state have persisted, and it has occurred to me that the computer is like a jet airplane for the mind. Even at the very beginning, the pioneers of the personal computer knew that how we interact with a machine was important. Doug Engelbart, the man who invented the mouse, felt his life's work was to help boost mankind's capability for dealing with complex problems. I know that not all designers use computers, but a lot of us do, and I started to think about what we do with our hands when we use 3D software. Mainly, we push buttons on the keyboard with one hand while moving and clicking a mouse or trackpad with the other. This system is ubiquitous and convenient, but I'm convinced there's room for improvement. I looked at other industries for examples of specialized interfaces: audio mixing boards, video editing workstations, and the control surfaces used for color correction in film. I wondered why there was no dedicated control surface for 3D software applications, and if we had one, what would it be like? One consistent pain point that was revealed by observing users was camera control. Moving and rotating the camera is definitely complicated, but it's also one of the most essential operations. I interviewed students, teachers, casual users, professional 3D animators, architects, graphic artists, and designers. I asked them all about the peripherals they use and why, but I needed some more empirical evidence. So I created the interface game and ran a series of trials. This game presented the player with 3 levels, each testing one of the most common types of interaction: pointing, dragging, and sliding. The response times were measured and recorded, but my secret agenda was actually to watch people's hands as they played the game. The next phase of research was looking at existing products. One product designed specifically for camera control is the Space Mouse, but I feel like it tries to do too much. I also looked at gaming controllers, which are well-thought-out solutions for navigating 3D worlds, but they require both hands to use and didn't seem quite right either. It seems obvious that designers would be interested in the latest virtual and augmented reality technology, and they indeed offer tremendous potential. But a trip to the school's VR lab showed that in practice, the technology is a bit cumbersome and the user experience can be disorienting and uncomfortable. This feeling was also corroborated by several professionals. I was really inspired by the React table, notably used by Bjork, which is a fun and unique musical interface that consists of a round table, the surface of which is also a display. The user, or users, place and manipulate various objects on the surface that represent different building blocks of music synthesis. I also searched for examples of tactile objects that are used in complex systems that might not be attached to a computer at all. In air traffic control towers, physical strips are mounted into a bay, and each one represents an aircraft in the pattern. Firefighters use a special table to keep track of personnel and equipment. This system is solid, reliable, waterproof, and doesn't crash. My favorite example, though, is the so-called Ouija board on an aircraft carrier. This is a scale model of the ship's deck with an elaborate system of models and pins that helps handlers keep track of the position and status of every aircraft on the ship. The bread and butter for 3D work, whether we're moving, scaling, or rotating, is X, Y, and Z. A burst of inspiration came from pondering a Rubik's Cube. I realized that you can rotate the faces in all 3 axes, and it visually corresponds to what's happening on the screen. I decided to focus my efforts on the concept of the cube and imagine how it could be used as a new type of interface. There were several things I liked about the cube shape. One is it would be intuitive. What you see is what you get. Secondly, it could be easily placed on your desk in any of the 6 isometric views, top, left, front, etc. Or to keep the cube at an angle, it could be placed into a beanbag on your work surface. Third, it would be fast. The next iteration of the concept is that all 6 faces of the cube would be touchpads, so you could point, click, drag, swipe, pinch to zoom, etc. This opens up a whole new world of possibilities for how the device could be used. It could work sitting or standing, at a desk or in a presentation setting. It could even be used for other types of programs. To make a prototype, I used an off-the-shelf inertial measurement sensor wired to a compact Arduino low-energy Bluetooth board. To create the software that could use this sensor data to control the camera in Autodesk Fusion took 5 separate layers in as many programming languages and almost 1,000 lines of code. I also spent a fair amount of time learning about quaternions, a mathematical system developed in the 19th century by an Irish fellow named Sir William Rowan Hamilton. I'll spare you the details, but quaternions are very important for 3D graphics, astronomy, robotics, and beyond. After a few days of additional experimentation and tweaking some more math, I finally realized the dream of moving the object in my hand and seeing the results on screen. In use, I found the concept to have real potential. When controlling the camera hunched over the keyboard and mouse, it seems more like work. When using the cube, it felt more natural and relaxed. It allows the user to sit back and ponder, which somehow fits the emotion of looking at the object you're working on from various angles. Doing this work has given me an opportunity to think deeply about user interfaces, ergonomics, and the practice of design. You design with your mind, but you use your hands to manifest your thoughts and communicate them. So what we do with our hands when we design is important. In the book Abstracting Craft, Malcolm McCullough said, "Hands are the best source of tacit personal knowledge because of all the extensions of the human body. They are the most subtle, the most sensitive, the most probing, the most differentiated, and the most closely connected to the mind. They deserve to be admired." My desire for this project is that it will inspire new ideas for tactile human-machine interfaces that will allow designers to feel more connected to their work. If our bodies are more comfortable and our minds more free, then we will be empowered to solve more wicked problems and to create more beautiful things. Designing should feel more like flying.